Problem 199, Classical Mechanics. The question is, a canonical transformation is performed on the Hamiltonian capital H is equal to small p square by 2m plus half m omega square small q square via the generating function f is equal to half m omega small q square cot capital Q. If capital Q of 0 is equal to 0, which of the following graph shows schematically the dependence of capital Q of t on t? It is given that the generating function f is equal to half m omega small q square cot capital Q. That is, the given generating function is a function of small q and capital Q. If the generating function is a function of small q and capital Q and t, then small p is equal to dou f by dou q, capital P is equal to minus dou f by dou capital Q, and h dash minus h is equal to dou f by dou t. That is, small p is equal to dou f by dou small q, that is equal to m omega small q cot capital Q, and capital P is equal to minus dou f by dou capital Q, that is equal to half m omega small q square cosec square capital Q. This is because d by dx of cot x is minus cosec square x. Let us give proper numbering. Let the equations for small p be denoted by equation number 1 and the equation for capital P be equation 2. Since dou f by dou t is equal to 0, we can say h dash minus h is equal to 0 or h dash is equal to h. Let it be equation number 3. Where h is a function of small q, small p and t, and h dash is a function of the new coordinate capital Q, capital P and t. It is given that h is equal to small p square by 2m plus half m omega square small q square. This is the given Hamiltonian. Now from equation 2, we have half m omega square q square is equal to capital P omega divided by cosec square q. This implies that half m omega square small q square is equal to capital P omega sine square capital Q. Let it be equation number 4. Now let us evaluate the term p square by 2m, which is the first term in the given Hamiltonian. For that, consider equation number 1. From equation 1, small p square is equal to m square omega square small q square cot square capital Q. Let this be equation 5. Now from 2, we have small q square that is equal to 2 capital P by m omega cosec square capital Q. Let it be equation number 6. Now substitute equation 6 in equation 5. We have small p square that is equal to m square omega square. Now 2 capital P by m omega cosec square capital Q, then cot square capital Q. Here m and m cancel, 1 omega cancel. So we have small p square is equal to 2m omega capital P, then 1 by cosec square Q is sine square Q, Then cot square q is cos square q by sin square q. The sin square q cancels. Therefore, small p square is equal to 2m omega capital P cos square capital Q. This implies that p square by 2m is equal to omega capital P cos square Q, cos square capital Q. That is, small p square by 2m is equal to omega capital P cos square capital Q. Let it be equation 7. Now substitute equation 4 and equation 7 in the expression for the given Hamiltonian. The given Hamiltonian is small p square by 2m plus half m omega square small q square. Now we have h dash is equal to h. Therefore, we can write h dash, that is equal to h, that is equal to omega capital P cos square capital Q plus p omega sin square capital Q, that is h dash is equal to omega p. This is our new Hamiltonian in new coordinate capital P. If h dash is equal to h dash of capital Q, capital P and T, then q dot is equal to dou h dash by dou P. This is the Hamilton's equation, that is q dot, that is equal to dou h dash by dou P, and that will become omega. That is q dot is equal to omega. Now integrate the above expression with respect to t. We have q of t is equal to omega t plus c. This is the expression for capital Q of t. It is given in the question that capital Q of 0 is equal to 0. It is given capital Q of 0 is equal to 0, and this gives the constant of integration c is equal to 0. Therefore, Q of t is equal to omega t. This is the relation connecting capital Q and t, that is Q of t is equal to omega t. So if you plot Q of t with t, it will be a straight line with a slope omega. Hence, option D is the right option.